Chapter 1, Section 2 begins discussing what matter is, and matter is going to be anything that has mass and volume. Volume is simply the space an object will occupy. Generally, we measure it in terms of liters or milliliters. If we're measuring a solid object, we might do it in meters cubed or centimeters cubed. A conversion that you should know is that 1 milliliter is equivalent to 1 centimeter cubed. Matter also has mass, and mass is a little bit different than weight. Weight is what we tend to think of the most because when we get on a scale, that's what we're measuring is our weight. Now, weight is based on gravity. Mass is not, and the units that we're going to be using for mass down in the lab will be grams, and sometimes we'll convert those into kilograms or maybe even into smaller units such as milligrams. When taking measurements, measurements can fall into two categories, qualitative or quantitative. Now, qualitative data are things that are not numerical, so there's no numbers associated with them. For instance, describing an object's color. I mixed two white chemicals, but I made a yellow chemical with them. That would be a qualitative form of measurement. Something like a comparison, this object is smaller than this object, or this object is heavier than this one. Those would also be forms of qualitative measurements. Anything that has a number associated to it is going to be considered quantitative data. So for instance, 47 grams or 102 pounds. Okay, those all have numbers and units associated with them, so they will be quantitative types of data. In science, we generally use the SI system of measurement or the metric system, and there are 7 main base units that make up this system. We will not use all of them throughout chemistry, but we will use a fair number. The first being length, which we'll generally use meters for. Mass will generally be in kilograms or grams. Time we will measure in seconds. Temperature, now this one's a little bit different. You might not have heard of it before. It's called Kelvin. Generally we use Fahrenheit or maybe even Celsius. In chemistry we'll use Kelvin a lot, and to get Kelvin you will take the temperature in degrees Celsius and add 273.15. That will give you the temperature in kelvins. The next one is the amount of substance, which is called a mole, and this one we'll use a lot throughout chemistry. Now, when you combine these base units, you can get a derived unit. For instance, area would be multiple types of lengths being multiplied together, and the same type of thing with volume. So a derived unit is just a combination of these base units. Some prefixes that you should be familiar with, and these are in your book on page 13, but some you should know just off the top of your head should be kilo. Okay, say we're talking about meters, your base unit would fall right here, that's where your meters would be, and then kilo would be greater than that base unit. Two that are smaller than the base unit you should know are centi and milli. So if we're still using meters, there are 1,000 millimeters in a meter, there are 100 centimeters in a meter, and there are 1,000 meters within a kilometer. Okay, so kilo, centi, and milli are the main prefixes that you should know. And in this system, each of these different prefixes are 10 units apart from one another. So, for instance, there are 10 millimeters within a centimeter. There are 10 centimeters within a decimeter. We will be doing many conversions throughout the entire semester. Now, a conversion factor is something that's going to relate two units to each other. So, the example here deals with metric conversions. The problem starts with 1.5 kilograms, and we want to find out how many grams that would be. Well, a conversion factor that relates kilograms to grams could be 1 kilogram is equivalent to 1,000 grams, or you could think of it as 1 gram is equivalent to 1,000th of a kilogram. Now, if I'm setting up my problem and showing my work, I would always begin my problem with the given information, the 1.5 kilograms. Then you multiply that by your conversion factor. Now, in this situation, we want to cancel out kilograms and convert into grams. So the 1 kilogram portion is going to go on the bottom of our fraction here. And on the top is going to be the 1,000 grams. That way, when you multiply the 1.5 kilograms times 1,000 grams and divide by 1 kilogram, your kilogram units will cancel out and your final value will be given in grams. This process is called the factor label method, and this is the method that I would like you to do conversions in throughout the semester. Another important thing to note is to always make sure that you are writing your units. So anytime you've got a number, there should be a unit associated with it. Make sure that you write those. It will definitely help in some of the longer problems that we do later on in the semester.